Yes, Jayesh, you are audible.
My screen is visible to all of you, sir.
Yes.
Okay. So hello everyone. Good evening. Today we are going to discuss about the basics of power electronics. As we always talking about EVs, in EVs we use controller, BMS. We have seen a lot of innovations and R&D. In that basics parts, we will see about the power electronic create a spiritual and a pictorial part of the controller functions. Like whenever when we are talking about the power electronics, it's whatever the switching and the efficient output value when we are talking about active component and passive components of the electronic. So we will talk about power electronics. Like power electronics create a crucial part in the EVs for in the basis of automation in the EVs industries, as well as for the energy storage, as well as for the power station. We all everywhere we use the electronics component, we use the basics powers of electronics. So in the basics power electronics, today's session is going to cover about introduction of power electronic, where we are going to see about we can use like in this session we are going to starting with the introduction of power electronic, where we are going to start with the basics like in power electronics when we are talking about. So you go with the fundamental of power electronics, where we are going to discuss about inductor, capacitor. It is available in every of the circuit. You can see the resistors, Zener diode, and many more devices like SCR, transistor, thyristors, along with the driver electronic conversion, like where we need a power conversion. Basically, in India, we have in two types of form of power, like AC and DC. So as per the requirement of the components in EVs or in any other field, like when we are talking about you are using smartphone, you are using television. So in everywhere, we are having a power electronic microcontrollers command on it. So as per the requirement, we can deliver the power, like it is supportable for a AC power supply or DC power supply. So we will see the conversion of power from one form to another form. Like when we are talking about in second topic, we are also seeing the power electronic components, like crucial components, which are SCR, MOSFET, IGBTs, which are work on for the high voltage and for the high connections. Like when we are talking about in EVs, basically, I hope most of us who are from the electronics background, they can know that switching devices like thyristors, transistors are always work on the low voltages, like for 5 volt or for 15 volt. But in EVs, they are being designed and being developed for a 0 to 32 volt of capacity range. So it can it can improve the lifespan, or it can improve the life, maintains the whatever the cost which we are giving in the maintaining, it should be not be given by the electronic sector. So they are designing power electronic component as per the requirement. Basically, all are the components of power electronics mostly are designable from the silicon and the silicon parts only. And in the basis of like they are having a type of N-type, P-type semiconductors, and in that they are having a majority charge of carriers, low majority charge of carriers. To flow from one form to another path, we use gains. Like we need an external power supply to make them ions active, to pass or to flow the current at a time of like when we are going to switch on the supply. So basically we are by hand, we are operating, we are giving some input to trigger that particular device. Like that, we to turn on that power electronic, we use gain power supply. So we will going to see like that type of components also. In along with that, we are coming with the DC to DC converter. When we are talking about electrical vehicles, we use DC to DC converters as per the power requirement of the auxiliary component, as well as the power required for the each of the components. Like when we are talking about controller. So in controller also, we having a lot of function and lot of features of wire. Like some wires are delivering power to the motor, some are delivering powers to the key switch, some are delivering powers to the Hall effect sensor, throttle connection, and they are different voltage range. Like we are giving 48 to 72 volt for a two-wheeler of the BLDC motor. But when we are talking about throttle connection, Hall effect sensor, we are giving 5 volt. So at the same time, that controller have a algorithm to give switching device connections along with the DC to DC converter in itself, like to step down to 5 volt, because that essential equipment like linear Hall effect sensor or minor IR sensors, they are working on the very low voltage. So we have to step down the voltage. And when we are talking about DC, so we all know that in DCs, we having a constant and stable voltage. So we can't use transformers to step up or to step down the voltage. So we will see all that type of things. Along with that, we are going to cover about the controlled rectifier. So rectifier is also creating a huge path, like when we are converting AC to DC while the charging of EVs. When we are charging the electric vehicle, we will find that we are having 2 types of charger, like on-board charging and off-board charging system, but where we are basically converting the power, and whatever the fulfill required for the electric vehicle, we are giving the power from from the substation itself. We will convert the power, or itself in some of the vehicle we having an onboard charger also, like we are giving a level 1 power supply, level 2 power supply, AC power supply to the vehicle, and they can itself rectify that and convert into DC power supply to charge the battery. Where in some of the rectifiers which are placed on the substation, which we also call as a DC fast charger, and these make a crucial role in the ecosystem of EVs and the development of the charging infrastructure. So rectifier, the basics of rectifier, we are going to see that what are the types of rectifier. So we are going to cover all these topics in this webinar. Okay. So I'm going to start with the power electronics. So in that today's webinar, I'm going with your childhood. Like we are starting with very basics, like what are the inductor, capacitor, diode, SCR, IGBT. So it may be a good recall about our childhood. So we are starting with the power electronics. Power electronics is a technology which associates with the efficient conversion and the control. Like we having a conversion command itself with the help of electronics. We having a full control on it along with the management of electric power. Like whatever the desired output we want, we can make that power as per our conversion circuit. Okay, so conditions of power by the static means from its available input from the input to desire the output form. Like whatever the desired output we are getting from the power conversion, it can be necessary and it can be filled by the different auxiliary component which is placed in the EVs. And when we are talking about normals, in the industrials or in the machines like CNC machines, they are having a different device. Like when we are in some of them, they are only work on the DC power supply. So another, we having a need specific rectifier circuits to run that particular component. So we are going to see all these types of things like power electronics converter, where we need to modify the electrical energy and modify it with the voltage, current, and the frequency. Basically, we having a full command on the voltage, current, and the frequency, means the parameters of the electricity. Okay, so somehow some basics examples which we are always see in the power electronics, like it is uses for the DC-DC converter, AC-DC converter, PDS, or computer, in any of the micro controller or nanotechnology devices. So we will find that we all are there running on the basis of power electronics only. So we will see that key concepts in the power electronic, like key concepts of the power electronic, like power semiconductor device, where we having, as I told, that they are working on the semiconductor device. So first of all, I clear that a semiconductor is a type of material which is not a fully conductor or not a fully insulator. So it is a bit mid of the material, like it can be energized or it can be act as a conductor at certain conditions or at a certain temperature. So that's why it is a very preferable choice for the making thyristors and the switching devices like diode, thyristors. So we majorly see like a silicon and germanium materials are used with the boron and the narrow compositions, where the covalent bond will act on the material and the ions are developed. As per that, we are working like a switching device. Like when we are talking about switching circuits, like it's basically the circuit convert between different voltage current levels. Like whenever we are see like AC to DC conversion, we will see not only always the sinusoidal waveform. There are several waveform with the PID controller. We will get up with the use of function generators. We are getting different types of waveform and the signals and error signals also, like square waveform, step index form, in discrete level waveforms. Types of different waveforms we are getting from the power conversion and the switching circuit devices. Where we are talking about EVs, along with that in renewable energy storage system, power electronics are integral and efficient, integral of the renewable energy sources like solar, wind power for the electric grid system. Like whatever the power we are generating, or for the MTH methods, like some small piezoelectric methods and some of the conversion where we use small turbines at your house to convert the some form of energies, like energies are never been created or not destroyed. So it can always change from one form to another form. Like we are converting from a mechanical kinetic energy into electrical energy, but where we can store the power. So we use like battery, we use supercapacitors in some states, like, but we need a bulk energy storage systems. We are having a lot of energy storage systems, but to store that power and in the uniform method, like where is the cell balancing and active balancing, we use also a power electronic circuit. Along with that, power quality and controls. So the power electronics are used to enhance the power quality of controlling of voltage current. We can have a full control on it. Along with the increasing and decreasing, we can regulate the speed, voltage variations, like we can say like throttle. In the throttle also we having a linear Hall effect sensor, like not a bipolar. It's a linear Hall effect sensor. With the enhancement or with the movement or in the particular angle, we having one of the magnets in it. And according to the magnet, we see the voltage fluctuation. That voltage fluctuation can improve the quality and control. Like we are getting the proper quality, like we are not getting any unbalanced output. We are getting a balanced output. Along with that, we having a full command on it. So at a certain point of view, you can accelerate the motor at different RPM, and the torque was different. At like we will see that torque characteristics and RPM, they are like RPM of motor, they are directly proportional, inversely proportional. So at a different acceleration throttle, you can do that. So we having a full command with the help of power electronics only. Like it is useful for the two-wheeler, three-wheeler, and four-wheeler. Wherever the connections of electrical controller, AC, DC driver circuit. Like whenever talking about controller is a hard part of EV. Without controller, you can't able to run the vehicle also. So in the controller inside, I will show one of the slide. I added one of the slide about the controller. In that controller, you can see that we having only the power electronics component inside it, and they are having different functions, different parameters, and different designings. Along with that, you can see that they are also working in highly based controllers, smart controllers, along with the, they are also working on their binary form. Like they're having a microcontroller itself, and they are working on the logic gates also, like AND gate, NOT gate. They are the basics we are going to see, like XOR gates. But while when we are designing any programming or designing any algorithm, it's a crucial path to peripheral that device and share the data at the time of conversion or at the time of delivering the power. Okay, so I start with the basics. Like whenever we talk about electronic, always come in mind like inductance, capacitance, and the resistance. These are the basics for the electronics. It is very lane terms for the electronics engineers and electrical engineers. Like we are using for the switching, storing, steering, resisting, and they having a different functions, and we are using that function to make or to provide a safety for the electronic components. Like we are using BMS, we are using like in BMS only, we are having cell balancing technique, active balancing technique, cell balancing technique where we having active balancing also and passive balancing also. In active passive, in both of them, we will see the power electronic components. In some of them, they are using ICs, which are having logic gates inside. In some of them, we will directly see like a diode resistor circuit, which will provide, and we will use to bypass the current from one cell to another cell while the charging or discharging time. So these three devices you can find every circuit, like inductance, capacitance, and resistance. So I start with the resistance. Basically, resistance, what is the resistance used? Resistance is used to opposes the flow of current. You can use for, we having the SI unit of resistance is ohm. It's very evident, you know also about that. But these types of things, basically, I have also added one of the animation. Here you can see that while it direct from copper wire, we having the flow of electrons. And from the resistors, the flow of electrons, they are interrupted or resisted. So the speed of flow of electrons are different from the internal point and for the external part. So we use different types of resistors like 1 ohm, 10 ohm, 2 ohm, 2 ohm. So how much you want to resist the power, or you use for the power conversion, or for a particular device, like we are using one IC, but to run that IC or to run that transistor also, we need a limited amount of flow of current to trigger that to supply that base, to supply that emitter connection. So we use resistors in all the circuits. Along with that, we are having inductors. So basically, inductor is also storing the charge as like capacitor, but in the form of magnetic energy. So you can see that wherever we see to opposes the flow of current, or you can store some flow of electronic in the magnetic flux part, we will use inductor. In your phone adapter chargers, we also having inductors in buck converter, boost converter, to stepped up voltage, to opposes or to absorb the heat part. We use the inductors. Along with that, they are having uses like tendency to conductor to opposes the changing in electric current. Like the changing, we will see like positive and negative flow, while in the AC power supply, we use inductor to provide a straight path. Along with that, we having magnetic field around the conductors. So it can improve the efficiency of the circuit. Along with that, when we are talking about capacitor, so capacitors are very widely used in the home appliances, in the industries, in the power electronics, or you can see in every small component to wherever you can store a charge, or where we need a high power, we use capacitors. Like it can charge the, and nowadays in EVs, we are coming, like Honda is also one of type of capacitors cell pack. All the capacitors are super capacitors, and they design that for their R&D and innovation part, where they have seen the high efficient power supply. But the drawback of that part is the drawback was there, like they can discharge the power at a peak time for a certain interval of time only. Like for a certain peak time, they can fulfill whatever the required energy, but it can't go for a long period of time, while the changing in the chemistry of the supercapacitor also. But we are having like normal capacitors for parallel connected to the load, parallel connected to the motors. We are using in home appliances, we widely use for the capacitor run winding motor, or capacitor run stop winding motor, induction motors. In your fan also, you will see one of the capacitor, which is from the 40 microfarad. So these capacitors are basically used to store the charge. Like I can say, like a one of capacitor, you need 100 volt. But at the back side, we are getting a 40-50 volt power supply. So how you can enhance, or how can you fulfill the desired output? So in that part, we will use a 50 microfarad or 40 microfarad one of the capacitor parallel with it, and we are giving power supply to them also. So at that same time, we are getting a power supply which can go to the capacitor. It can store the energy at a time when we need to initially thrust the motor or for load, it can deliver power at the same time. So whatever the desired output, like for 100 watt, we are desiring, it can be fulfilled by the supercapacitor. So in any of the electronic part, you will see resistance, capacitor, and inductors. So it is a crucial part for the power electronics. Like in the power electronic, we are having SCR, transistors, IGBT, FET, MOSFETs. To protect them and to give a proper output power supply, also we use these basics components of electronics. So I also told that we are going to talk about power electronics converter. So in first of them, I have placed rectifier. What is a rectifier? Basically, we are converting power from AC to DC. And we are using in the electric vehicle, it is used for the charging purpose. And some of the converter, some of the four-wheelers we are using for the, we are using for permanent magnet synchronous motor. We are using some of the induction motor. We need like DC to AC conversion, where we convert in the rectifier. Basically, we used for the step, basically while the charging of electric vehicle, we can convert AC into DC in electric vehicle. Or we having a onboard charging, which having a rectifier circuit in it. I will go with the deep in rectifier only because we are more focusing on the electric vehicle only. And when we are talking about inverter where we convert DC to AC, it can fulfill whatever the required output is with the variable frequency by the inverter connection. You can see in your household also, like you have installed it for your backup power supply. So to fulfill that backup power supply, we use inverters for your in industries as well as your home appliances. You use inverters. Along with that, we are having choppers. We call it choppers, or you can also call it as a DC to DC converter. It is also a major part of electronic devices in EVs. While it step down the voltage for two-wheeler, for three-wheeler, for four-wheeler also, like to ignitic start the engine of vehicles for a automobile, we use 12-volt battery where we step down the voltage for some of the peripheral device like ALU is used. ALE and ALU are used to provide a power supply to the AC, music system, navigation systems. So we use different supplies. With that, like cycloconverter are used from AC to AC converter. Basically, we are using AC to AC converter to enhance the frequency of circuit. Like we are getting in India 50 hertz of frequency, but many of the motors, controllers, and they are, when we are passing through that, we can enhance the frequency up to 2.4 gigahertz. So with the help of power electronics only, we can enhance or we can convert the power. While when we are looking at special techniques or innovations like wireless power transmission. So in the wireless transmission also, like we are having a primary coil as well as secondary coil. So we can change in one form to energy like AC into DC. Then we are giving to the primary coils, and after the mutual induction process, we are getting some power in the secondary coils, and that power is again then transmitted with the help in the DC to AC with the uses of some of the inverter circuits, and we are getting a different variable frequency itself in it also. So it is very useful. In the form of electronics, we use all these four parameters with the different appliances. Like they are having a type in choppers, they are having class A, class B, class C. Cycloconverters also having a different types of complex as per the requirement, as per the functions they are used in the market. Or you can see all of the components are having a particular or specification path. So I start with the rectifier. What is rectifier? A rectifier converts alternating current into direct current, means AC to DC. And we are using like a PN junction diode in its. Okay, so basically PN junction indicate about the P type of semiconductor and N type of semiconductor. As I mentioned that all the switching devices are made up of semiconductor, and for N type and P type, they are basically doping with each other. And along with that, the majority charge carriers and the majority minority carriers, they are having electrons and holes. And according to the power supplied to them, the flow of electrons from valency band to electron band. So the gap which be energized or the latching current, breakdown voltage current, there are very different prime factors we will going to see in the diode part also. But when we are talking about rectifier, we use diode as a preferable choice, or diode is one of the component which is used work on the forward bias connection. So it can't work on the reverse bias connection. So we use two step to convert a form of energy AC into DC. So rectifiers are two types: half wave rectifier and full wave rectifier. And we can also categorize them full wave rectifier into two parts, like a center tap and H bridge rectifier. So they are having different priorities and different functions. In that, like a half wave rectifier. In the half wave rectifier, we are converting a half cycle of the AC to the positive half cycle. While when we are passing through a negative, you can see that it can't pass through it. Like I will show you from the animation only. Like when we are talking about, it can pass from the positive half cycle. So you can see that the diode is passing them to make a signal as output signal. When they are coming from negative point in the negative half cycle, we can see that diode is not passing them, or the signal is not being generated. Okay. At this time, you can see that the power is not being passed by the diode, like because diode always work on the forward bias, they are not working on the reverse bias. For the reverse bias, we also having Zener diode, and they are using as a voltage stabilizer for the voltage regulation circuit. So we use that Zener diode for a different functions. As we mentioned that full wave rectifier, the full wave rectifiers are basically converting both the cycle, like positive half cycle as well as negative half cycle of the rectifier, where we see that bridge rectifier and center tap rectifier. In bridge rectifier, we use 4 diodes to convert the half cycle of input and half cycle of the input of AC for positive half cycle, and second 2 diodes are used for a negative half cycle and can make a proper proper DC constant voltage. Where we using about center tap rectifier, we use one of the transformer in it. We used to divide the power, and from the power supply, we can see that make a path for a positive half cycle and for the negative half cycle. From the circuit, you can better analyze that. Like these are the circuit for the positive half cycle of a center tap rectifier. Center tap rectifier, why we call as a center tap rectifier? Because we are using one of the transformer, basically, which are center tap transformer. Like primary winding having one of the mutual coil, where when we are talking about the secondary part, in the secondary part, you can see that positive wire as well as negative wire. But in between of that, the one of the wire is connected, and these wires are used to make a connection for the returning path of the flow. Like when we are giving a positive half cycle, you can see that the power can flow from the positive point to the positive to the ground, and we will get a positive output. And when we are in that case, D1 is active. Forward bias D1 diode 1 is active, and it making a closed circuit, and the D2 is an open circuit, where we call as when we see the negative half cycle center tap rectifier, we will see the negative path, like a sinusoidal waveform, where the negative half cycle is also making one of the signal. Like it can flow from the negative path. This time, D2 is a forward connection and D1 is an open connection. So we are sweeping that in the basis with the connections or with the uses of switching, and we are getting the output. But it is more complex as compared to H-bridge rectifier, as well as we use to convert one of the cost of transformer also. So we basically use for the practical and in some of the limited appliances. But when we are talking about bridge rectifier, it is very widely used in any of the, like in the PID controller, in the loop controllers or feedback loop or open loop controllers. You will see that H-bridge rectifier is a more preferable, because at a time, two diodes are active, D1 and D2, and it can make one complete cycle. And at the second time, when we are giving for the negative half cycle, at that time, D3 and D4 are active. So while the positions from energy can be passes through the diode from positive point to negative point, and it can create we will getting a complete half cycle. Like in the DC, in the bridge rectifier, where we giving a power supply from positive cycle, we will see that the diode is passing from D1, and from with the help of resistive load, we are again it's passing through the D2, and it can create a closed loop circuit here. As well as when we are talking about in the negative half cycle, you will see that the negative half cycle can be covered from the D4 to D3, and making again a closed loop circuit. At a particular time, two diodes are active and two are in the off region. So these are the basics fundamentals which we have seen in the power electronics, like in the rectifier. So today's we are discussing, as we are having major focus on the EVs, like the role of power electronics in electric vehicle. Like when we're taking about example of two-wheeler. So we having in cluster panel, we having 3 GB RAM, octagon processor, we having a microcontroller itself in the Ola scooty also. So but for the navigation system, for the Bluetooth module connections, for the speakers, for connection with your SOC estimation of the battery, we use lot of electronic circuits. And these electronic circuits are designed, and each of the circuits, they are having lot of components. Like there are around 100 small components, or maybe in BMS itself having 780 components, which are in the nano forms. So these are the very deep or nanotechnology components are used in the assemble in the PCB of power electronics. The role of power electronics in electric vehicles to accomplish and the conversion of battery supply, like battery supply, we are giving a DC to alternative current for the electronic motor, like when we are using a BLDC motor for two-wheeler, three-wheeler, or when we are talking about permanent magnet synchronous motor, we are giving a power supply of DC power supply from the battery pack. But somehow controller is also working with the switching case, and we are using MOSFETs. In some of the controller, they are using IGBTs. They are having a full command on it. And as per that, we are getting a trapezoidal waveform. Somehow, we are getting a positive half waveform as well as a negative waveform, because we have to create a magnetic poles inside the motor. So the north pole and the south pole was magnet should be created with the flow of current only. So we have to make, or we have to generate the power in the form of AC. So we use different controllers. When we use, as I mentioned, that DC to DC converter for the regenerative braking system, for efficient distribution of power for each of the devices. As I mentioned that in the controller, like we are having throttle. Along with throttle, we are having brake cut switch. Along with that, we are having auxiliary component connections, anti-theft system connections. Along with that, we are having a lot of wires for the peripheral device, for the CAN communication, for the VCU connections. So in every different wire, we are having running with a different voltages. So controllers itself having a DC converter, DC to DC or DC to AC converter in itself only. So we see lot of components, but some component which having a power electronic component inside it, like a small SCR, transistor, rectifier. I will go all of them, but I will explain some of the components. Like we use inverter. where we use inverter in the DC power supply. Like we are using for the driver circuit to run the motor, to run the peripheral device, which is the efficient part of the EV powertrain, where we are transmitting the power from one part to another part to propel the wheel. Or these are the part of inverter, with where we are changing DC into AC form with help through the controller converter. When we are talking about DC to DC converter, basically DC to DC converter, as evidently somehow in some place we called boost converter, and in some place we called as a buck converter, or in some place we also called as a buck boost converter. So that concept, buck converter, boost converter, basically it's changing the voltage levels. Like when we're talking about boost converter, it can step up the voltage at the output side. When we call as a buck converter, it can step down the voltage at the output side. Basically, we are using buck converters in two-wheeler, three-wheeler. In the four-wheeler, we also use like boost and buck converter वाली V2G connections. Buck boost converter वाली V2G connections means vehicle to grid connections, charging infrastructure. In some of the countries, we are using that. Along with that, we are having topic about BMS. As I mentioned that in BMS, we are having 780 components, which are basics functions for to under cutoff voltage, under load, for overcurrent, for temperature connections. So we use a lot of BMS. We use in that BMS we are having MOSFETs, ICs, which are having for the special functions, which are BMS, which are supportable for the regenerative braking system. The BMS which are having along with the safety equipments like resistors, capacitor, diodes. We are having some transistors to bypass the current, for the cell balancing techniques, for detection system, for SOC estimation, for monitoring parameter. We use a lot of the electronic components in the BMS on. It also connect each of the cells from the particular row and connections columns to get the responses of battery BMS system. As mentioned that charging system, we are using onboard charging system inside the vehicle, which is one of this one is one of the picture of onboard charging station, where we can giving a power supply of AC power supply as an input in the inlet of four-wheeler, and we are getting output of DC power supply, which is also connected with the super capacitors, and whatever the desired output we are needing to fulfill to charge the vehicle, it can be given by the DC. It can be given by the onboard charge. Okay. Along with that, when we are talking about regenerative braking, so it's a very crucial topic, like regenerative braking. While running of the vehicle, while applying a braking on the vehicle, we are creating an energy on it. So in that point, we will like where we can store the charge. Like we can directly give that particular energy to the battery pack, or somehow it can be stored in some another place. So for that also, the device which are used like regenerative braking component, MCU, VCU, they are having different components, and they are having a super capacitor in itself. While somehow, if the super capacitor is fully charged at that particular point, it can discharge the capacitors are discharged, and they can store that charge into battery pack, or you can say as a traction battery pack. While when you are running the vehicle, it can store, while capacitors are charging, after a certain charge, it can discharge, and that charge is going to be stored in the battery traction pack with power passes through the BMS. So the BMS is also having a response, like it are getting a proper voltage or not. So these all are the parameters which are, or the algorithm which are designed by the technicians or engineers. So they are having different operations, and they are having good command on the power electronics. So the power electronics is a crucial part for the EVs as well as any of the autonomous automation companies, along with the CNC machines. They are having PLCs. They have the, or you can say as an embedded part. Like wherever we can see a software as well as a hardware part, we can relate that we have lot of the power electronics component inside in it. Like it is mentioned that motor control. So in the motor controller, there you can see that they are having a lot of wires, like for a brake switch, for power delivering, for power input, power output, for a steady self condition, crucial controls. So they are having a lot of connections, and these are having different, they are connected with the different peripheral devices. Like I will show you one of the picture of cut section of controller of two-wheeler. It is connected with the BLDC hub motor in the scooty. And you can see that we are having capacitors, resistors, bypass transistors, nano resistors. Along with that, we are using MOSFETs, metal oxide semiconductor field effect transistor. So these all are the controllers are used to convert the power from DC into AC power with the trapezoidal waveform to run the BLDC motor. Like these are the controllers are sensor-based controller. Like they are working on the responses of Hall effect sensor. But some of the controllers are also there which are sensor-less. But at that sensor-less, the algorithm make a crucial part to run that particular motor. So in that power devices, like I mentioned that power electronics. So power electronics, we are having lot of devices. In basically we use diodes. While you see that in the rectifier circuit, we use diodes. We are having thyristor family. We are having a transistors. These all are devices having different peripheral connections. In the general purpose, they are having uncontrolled value, the power delivered by the diode. When we are talking about thyristors, we are having silicon rectifier, silicon controlled rectifier, UJT, RJT, MCT, and lot of the components which are working for the high voltage as well as the low voltage. Transistors as well as transistors are basically we are using to amplify the signal, like amplify the signal or to boost the power flow, or we can also use for the conversion part, like MOSFET, IGBT. They are having common base, common emitter. Like you can see, like in most of them they are having same type of configurations, same names, but in some like MOSFET, they are having drain, source, and drain. So these are the terminal names of the power electronic components, and we will see all of them. Along with that, I mentioned about diodes. So diodes are working on the forward bias connection. As I mentioned that it's working on N type and P type. So they are working, they are having anode and cathode, where we are giving power supply for a positive part. At while the doping, we are having one depletion region in the diode, and that depletion region, the ions can change from P type to N type. Basically, N types are having a majority charge carriers, and always P type of flow of electrons can pass from there. At the potential only, we are getting a certain voltage. At that voltage, we are using for to from N, flow the power from N type to P type, and it can make a switching the connection at a certain temperature or at a certain voltage to trigger the connections, or we can use for a forward connection, or for the for a, like we can bypass any of the, like we are using this in the solar power panels also. Like we are having each of the cell modules are connected in the solar power stations, but in somehow one of the panel is faulty, or it's not working properly, but somehow it can absorb the voltages. To how you can bypass the power flow? So we basically parallelly connect one of the diode in each of the cells, and we have seen that while even if one of the control panel or cell is not working, it doesn't affect any of the another cells which are connected with the parallel or series in the connections. And whatever the desired output we are getting, and somehow we are having unbalance on it, and it can be rectified. So these are the diodes are used for the bypass connections for the electronic circuits also. So when we are talking about transistors, the sections that supply a large section for the majority charge carrier. Basically, you can say that these are the two diodes. They are having two type of diode, like emitter base and base collector. they are having a different doping. NPN type and PNP type means in that NPN type N semiconductor, again we are having P semiconductor, and again we are having N semiconductor. So basically is added of two diodes, and they are working for the amplification of the signals and for the evident operations. Like we are having cutoff mode, saturation mode, and active mode on it. While when we are supplying a different power supply, like from one side we are supplying basically these transistors having three terminals: emitter, base, and collector. In the emitter, base, and collector, we are basically to trigger or for in the base part we are not giving up any power supply, which we are giving from the negative or positive. From the basically we are getting a control emitter, base, collector. From the collector we are getting an output waveform and output power supply, which is evidently positive and negative, while the transmitting the power supply through the transistors, while the emitter and base in the cutoff region, when as a first mode of operation, we see that emitter and base and collector to base are reverse bias. We are giving our connections as a negative power supply, so the no current will flow from the device. When we are talking about saturation mode, so in this, both the junction of transistors are connected with the forward bias connection. So we are giving positive supply to the base connection, and the flow of electrons are from the huge part, and the control current will flow from the base to the transistors collector, where we will see the active mode. In the active mode, we can see that emitter to the base of forward bias and the collectors to the for reverse bias. Like these are working a flow of from positive to negative, and from negative to positive we are called as a reverse bias. And these are the operations which we have seen in the transistors. Along with that, when we are talking about thyristors, so the thyristors are basically performed to action the switching as well as for the rectification. Like we are using SCR. In SCR also, we are having two types of connections. Along with that, we are using to trigger. We are using gain infrastructure. So we are using gain power supply to trigger the thyristors. Like they are having three terminal: anode, cathode, and gate. For the conduction to take gate to trigger with a pulse, we generally give a pulse generation signals, like you are giving high signal or low signal to trigger the gate or to transmit the power from A to C. Like it's a similar like one of the switch. While your switch is in off condition, when we push that switch, the supply is going on. So like that only the gain is acting here. So you have to give any external power supply to trigger that particular command. We are having SCR, DIAC, TRIAC. Basically, DIAC are having they are having two diode connections along with the TRIAC, UJT, BJT, MOSFETs. MOSFETs are basically we are using in the electric vehicle for the controllers. In controller, we are using MOSFETs for the switching devising. For to make a trapezoidal waveform. Along with that, we are using IGBTs also for the high voltage correction flows. Along with that, we are having these all thyristors having different VI characteristics. Like in that VI characteristics, they can operate at certain voltage. They can operate with a different latching current, holding current, and they are having different functions. Like when we are talking about latching current is that a minimum current that flow through the device in the forward bias condition. So they are having different parameters. When we are talking about holding current, the holding current is a minimal current that flows the device in the forward condition, but below the particular value below the particular value, the device will stop. Means basically one of the slope and at a certain temperature, it can hold the power. And if you are not giving a regular power supply, it can disconnect the power supply and your switch is not going to act. And like we are using these VI characteristics, power electronic devices in each of the circuits. So you will see that like they are having breakdown voltage also. Like when we are using chemistry of silicon material in it, so we are having a 0.3 volt. or 0.3.7 volt. They're having a variation from 0.3 to 0.37 volt in the silicon material. When we're talking about germanium, we will see a lot of the configurations, while when we're talking about germanium, we will see 0.7 and 0.7 to 0.8. They're having a variation. Like in different part, you will see like different types of the things. Like when we're talking about silicon-based semiconductors, wide band gaps where they are between to overlap the flow of electrons from one atom to another atom. So these are the part of internal part where the semiconductor are more efficient and can withstand with the high temperature. And the silicon components, that ability to operate the controller at a high temperature, high efficient in while to optimize or the performance of the battery with a certain unregulated power supply or unbalanced condition also, they are acting properly. And due to the basic knowledge about all these power electronics, you have to cover all the basics connections, like whatever the connections in the controller. To analyze the working, we need to know about all the basics component. Like when we are talking about VCU, we are having a lot of connection in the dashboard of electric vehicle. Like we having a speaker connection, AC connection, navigation system. We having and along with the anti-theft system, range estimation, speedometers connections, digital form connections. We are having evident Bluetooth module connections. So all these devices are connected with the electronic part. We are giving a power supplies from the electrical part for to trigger that particular device at a particular level, that voltage are fulfilled by the AC converter, DC converters, choppers, buck boost converters. Along with that, we are using cycloconverters in the part of EVs, but we are required, like when we are talking about vehicle telematics, in the vehicle telematics also you can see that the appliances which are connected with them, like for the navigation system, just I take an example of navigation system only. So we are using like the GPRS model. We are using a navigation system which is connected with the IoT, where we can get collected data from the internet, and we are getting or we can track anyone. So these are the features which we are getting as a luxury features in the EVs. Are all these are or you can also see that when we are talking about four-wheeler, we call as an EC, electronic control unit. Basically, whatever the CAN communication, the data should be transferred from the each of the EV powertrain components like battery, controller, BMS, master BMS. So they all the data should be interpreted with the uses of microprocessor, microcontroller through the VCU connections, and these data should be in the basis of signals on. And many of they are in the binary mode, hexa mode, or octa signals, and these are not be understandable by us. So basically, they are in the term of 0, 1, 0, 1, 0, 1, and 0. So these responses signals are also be changes in the form of high level language to understand for the user friendly, and to understand by the from us. We use assemble technicians. Along with that, we are using assemble ALU controllers, which are they are converting analog to digital converter, and we are getting a proper output. Like when we are talking about multimeter only, let's take an example of small equipment which I hope all of you know about, like multimeter. We are checking the connectivity. We are using voltage power supply. We are checking the different voltage, resistance, controller connections, continuity. Along with that, we are working for DC power supply, AC power supply. So these, we are all getting the signals collected by the while touching the two terminals in it. But how you are getting the data in the form of one or in the numeric form to understand by us. So they are having a ADC converter in itself. So these are also an example of the power electronics. So wherever you use a smart, or you can understand any of the signal of power of electric flow, or using like battery meter, or we are getting some digital output from any in the your home also, like in your thermometer. While you are ill, you are also checking the responses. In that also there are power electronic components. So it is widely used from everywhere in, I hope everyone have also that type of power electronics, but you have to understand some of the connections. And when we are talking about EVs, in EVs ecosystem, it's take a very crucial part for the autonomous, for luxuriness, for whatever the drawbacks, or we can say a loophole of EVs, it can be improved by the power electronic only. Like we are having a drawback for EVs, like limited drive range. So we are working with the charging infrastructure. So again, we are having power electronic connections. We can having a battery pack optimized connection. We are not getting a desirable output in some of the faulty conditions, and we are not in the real time. Like companies are having a range of 100 kilometers, but at the real time, and your as a Indian roadways, we have seen a lot of complaints, like service complaints, like they are having they are not getting a desirable output as companies are guaranteed like 100 kilometer or 120 kilometer. But due to some unregulation power supply and due to some of the cheaper components which are there also, and we are not able to, or you can't handle some of the faulty conditions in your EVs for a two-wheeler. Basically, I've seen this in the two-wheeler. So this is from my side. If you have any query regarding any power electronic components, so you can ask. If you have any queries regarding power electronics, or you want to ask any questions related with the electric vehicle, you can feel free to ask the question.
Hello. Yes,
Yes, sir.
thank you very much for such elaborative session. And I'm Dr. 𝒆𝒆𝒆 Singh.
Yes, sir.
I wanted to know, are you able to hear me, sir?
Yes, sir. I am able to hear you.
Is there any advantage over the PN type of junction to over NP? You just told that for triggering semiconductors are just PN and NP.
Basically, sir, we are highly doping with the N type of semiconductors. We are mostly use NPN connections, transistors, thyristors in the electronic appliances. We are not using PNP because
that is what my question is, whether this PNP NPN has some advantage over the PNP.
Yes, sir. There are advantages, like they are having a control in it, or the majority charge carriers on it, so it can easily regulate the power from. It can pass from N type to P type very evidently.
Okay.
Okay, sir.
And
Thank you.
so the second question was that you see full type of
full type of rectifier, full wave rectifier.
Full type of rectifier, and you just given two semiconductors which were acting on secondary side. So this full type of rectifier must be of NPN junction with this NP junction. Or
basically in rectifiers we are not using N. We are having like diodes in it. So the diodes having only one junction. With junction we also call as a depletion layer. And at a time where we are talking about full wave rectifier, we are using in H-bridge rectifier, we are using 4 diodes. Two diodes are working for positive half cycle of AC signal, and 2 diodes are working for the negative half of AC signal to convert into DC system. And from when we are getting the DC from the full bridge rectifier also, there are also some ripple factor we have seen in the cathode CRO.
Smoothing must be I think capacitor and
So to overcome from the ripple factor, we are using capacitors and some of the protection circuits.
Very good. Thank you.
Okay, sir. So if you don't have any queries, I'm winding wind up the session from my side. So concerned team will take the call.
Okay, very good. Thank you. Thank you very much.
Thank you.
Thank you.
Okay, thanks, Jish. Thanks for hosting the webinar. Your expertise and insights were invaluable for our learners. I would like to take the opportunity to introduce our company ISIE India products and services that we offer in EV technology with small video. So learners kindly have a look with the small video.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Very thanks, learners, for watching the video patiently. So, any of you want to enroll in the course, kindly send us inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future.